please stand by as we beam aboard our next presenter, Staff DevOps Engineer with Adobe, Grant Soya.
Good morning, and welcome to an OCSF Odyssey, trials, tribulations, and hopefully some triumph. My name is Grant Soya. I'm a staff DevOps engineer with Adobe. Before Adobe, I worked at a satellite imagery company called Maxar, and before that, I was with the University of Colorado at Boulder. When I'm not at work, I like to ski, hike, and run. Right now, I'm training for a marathon, and I'm at that point in training where I'm seriously doubting my hobby choices. All right, so our agenda for today, we're going to start off with a story and then move into some of the challenges that we faced in the real world. We'll go over some of the decision points and then talk about the journey and hopefully finish with some learnings. So starting with a story. Imagine that you are a security engineer. Not too hard, right? So you are asked one day at work to come in and select some timestamp data. So we want to pull out a timestamp and a source IP from this data source on the right. So the difficulty in referencing one schema is pretty trivial here. We look at our select statement on the bottom, and we can see that we can pull this data out without a whole lot of difficulty. So we're feeling pretty good about ourselves. Just need to add experienced data engineer to our LinkedIn page, and we're good to go, right? So what about if tomorrow rolls around and we add a second data source to this? Now, if we look at the right, we can see that there are a few changes. The timestamp format's a little different, and we've got some different casing in our field names. So it's a little bit trickier to handle, but no problem. SQL wouldn't have union if we weren't meant to use it, right? So we union this all up and go home, and we're still feeling pretty optimistic about how this is going. Oops. There we go. So what if we come in the next day and we add a third data source? And this third data source has made some really interesting schema choices. So not only do we have this crazy long field name, but we also have a very long or a very nested field containing our source IP. So no problem, we'll whip this up on the bottom. And let's take a look at this query real quick. Just glancing at this, who here thinks that there might be a bug that I've introduced in this last statement? And who here, after I ask that question, thinks there is definitely a bug in that last statement? So there is, in fact, a bug here in the concat that we would join all these numbers together without a separator. So if we're looking for an IP address, this is probably not going to be very helpful. So at this point, you might be wondering, is this the best path forward? And what is someone who gets this after myself going to do if they have to modify this or continue extending it? And is there an easier way? So hold that thought. Let's talk about the challenge that Adobe faced in the real world. Like a lot of large companies, we are a creative company. We've grown through multiple acquisitions, and the result is that multiple teams are doing the same thing a lot of different ways with very little standardization. We are 2+ years into our partnership with Cribl, and we're processing around 100 terabytes a day through our Cribl Stream environment. Our team specifically is tasked with working to enable security at scale. So we're responsible for building and maintaining a mix of vendor and homegrown tooling that performs various functions across Adobe's security platform. Like a lot of companies, Adobe is required to maintain compliance with the latest PCI standard in order to handle credit card transactions. As it turns out, people like paying with credit cards, and we like getting paid for our services, so it's a win-win. A loss of compliance would mean immense loss of revenue and incalculable reputational damage. One requirement that's come through the latest PCI standards is implementing web application firewalls and monitoring for signs of malicious activity. which led us to a decision point. First, do we even need a schema? Can we get by with what the vendors give us? Well, as we saw from the story up front, it is an option. We can do it. A schema will need management over time, as well as change management processes if you're using the schematized data in critical workflows like compliance. Your costs are going to be higher because typically the schematized data is going to be larger than the original raw or vendor schema data. And your compute costs are going to add up as well as you get into terabyte or even petabyte scale. So we think we need a schema. Our options then are going to be buy, build, or adopt. Now, one of these we can knock out pretty easily. I'm sure someone somewhere will sell you a schema and maybe a bridge to go with it. But realistically, your choices are going to be between building or adopting something existing. So Adobe's first effort in this area was building, because how hard can it be? So as a demo of this, let's talk about field name formatting. So if you are designing a schema, show of hands, who would put all your field names into camel case? Not a lot of camel case fans. How about snake case? What about team kebab case? All right, last question, show of hands. Who thinks that if we all have to agree on one of these to use everywhere before we leave this session, that we're going to be late for lunch? So our initial efforts kind of bore this out. We developed a homegrown schema, but it met the compliance goals without really addressing the needs of our internal customers. It was limited in what we could accomplish with it. It was more difficult to think or to agree than you would think, to agree on a schema and how we should map data within that schema. Now, I'll call out that this may be an option for you if you have something very unique or very unusual that you're trying to map that existing schemas may not be a good fit for you. But for most of us, the right option is going to be to adopt something. So let's talk about OCSF. OCSF is the Open Cybersecurity Framework. It's gained a lot of traction recently thanks to AWS Security Lake, making it the de facto standard for their product. And importantly for us, it had a very active open source community. There's a lot of people interested in it, so the odds of it becoming abandonware are hopefully lower. I will call out that you shouldn't spend too much of your time obsessed on what the right schema is for you, because the right schema ultimately is going to be the one that you can actually build consensus and agreement around and commit to implementing. For example, OCSF lets us choose that snake case is apparently the winner. So if you're team snake case, congratulations. So let's go through our journey to implement OCSF. Now, this is a technical talk, so you might be looking at this slide and asking, why am I starting off with messy human factors as the first step in the journey? And that's intentional. The biggest obstacles that you face with this sort of project are not technical. Disagreements about how you map data, where you map data, are going to be far more challenging than the actual implementation of those mappings. If you invest the time to align the people involved before you start, it will pay off for you down the line, I promise. So how do we go about getting that stakeholder buy-in? We can do it by following a customer-centric approach. We want to check in regularly with our customers to maintain a good working relationship and ensure that the end result is meeting their needs. We also want to be receptive to their changes or suggestions for improvements. People like to be listened to. I also want to call out that standards like OCSF are great, and you should follow them because they save you time, but make sure that you're still delivering what your customer needs. So let's go through real quickly what our architecture looks like as part of this project. So you can see over on the left side, we have different sources of WAF data. We have AWS, we have Azure, we have Cloudflare, we have Akamai, we have ModSecurity, and we have others that didn't fit on this diagram without it getting ridiculous. From all of those, we have different integrations where we land data into S3. From S3 goes into SNS, SQS, and then is picked up by our Cribl worker groups. Those are scaled in auto-scaling groups running EC2 instances. Cribl performs the processing, and we output to a data lake, which is S3 based in a different account. So now that we've covered the big picture, let's talk about some specific implementation details within our code. So first of all, we structure everything for OCSF within a pack. If you haven't seen packs within Cribl before, they're a great way of containing different configurations. You can put routes, pipelines, now sources and destinations, along with sample data and lookups and several other items, all in one nice, easy to manage form. For OCSF, we do one pack per category class combo. So for WAF, that gives us network and HTTP activity. And we also do one route per vendor. Now, some of you might be looking at this and say, why not just have one pipeline? This is one type of OCSF transformation. Why not just have one pipeline? And this was, in fact, where we started. And what we discovered very quickly as we started adding additional vendors is all these different conditionals become challenging to manage. You have AWS data that is picked up by a ModSecurity rule, or Akamai data that runs through a Cloudflare rule. And all of a sudden, you have these bizarre transformations that come out to your output. And it's very difficult to backtrace which pipeline or where in the pipeline that transformation or that error occurred. So splitting out by vendor gave us some more flexibility in debugging that. Now, this does introduce some duplication. So how can we rein that back in and not have the same thing all over the place? Well, one of the functions that we use liberally is the chain function. Within each vendor pipeline, we chain to common aspects of functionality that are contained in other pipelines. For example, we have one common pre-processing pipeline where we perform that the extraction of all the fields and the flattening into a dictionary that we reference later. Benefits here are consistency and time savings when you make changes. It's a lot easier to break things in one place, see that it's broken, and go fix it, then try and make the same change in multiple places and make sure that it works everywhere that you changed it and that you haven't missed anything. If you've worked with Cribl at all, you've likely seen eval. This is sort of a fundamental building block for most pipelines. Now, eval gives you some good guardrails to make sure that you don't do anything funky with your JavaScript and introduce some bad behaviors compared to code, and it can be more readable. But there are times when code gives you necessary flexibility or the option to have a more readable transformation as compared to an eval. I'm going to pick on nested ternary operators a little bit here. So the top right block shows you a logical expression with nested ternary operators, which if you're very familiar with these, maybe this is easy to read, but for most of us who have a programming background, the bottom right is going to be pretty readable and comprehensible if we have to come in and figure out what this pipeline is doing. So I personally would avoid the nested ternary operators. We also heavily use lookups. These allow us to have repeatability in these large statements that would otherwise be conditionals. You can see on the right, we store lookup for OCSF action IDs to map a numeric value with the action taken. We also use lookups to handle all of the mappings of fields in source data to the OCSF mapped field. And for some of these lookups, we tie in external processes using AWS Lambda. So we can run a Lambda function to reference data stored elsewhere on a schedule, and that can call Cribl and automate the updating of that lookup without human intervention. Regex is something that if you haven't caused a major outage because of regex, don't worry, you will. While extremely powerful, they can make troubleshooting very difficult and make maintaining code very difficult. So let's have an example of that. Who here in the room, raise your hand if you can look at this and tell me exactly what it does. And I hope no one's raising your hand right now, because if you are far stronger at regex than me. For most of us mere mortals, we'll decode this. You would use this to validate if a password matches this condition. But Hopefully, you can agree with me that this is perhaps not the easiest thing to read at first glance and immediately understand what it does. So use regex if you have to, but be aware that it can cause some problems for you. You also want to be mindful of using try-catch blocks. Cribl in a code function does a really good job of making sure that on failure, it doesn't just drop your data on the floor. This is usually good. We like to have our data not disappear out from under us. However, if you are relying on the code block to do a transformation to your data, then downstream in your pipeline, this can cause knock-on effects when something doesn't happen, and those can be pretty tricky to debug. So one of our common patterns is to always use these try and catch blocks and capture the error in a specific key. We can then look for that key in our output routers and send those events to Splunk for further debugging to figure out why they encountered an issue in our pipeline. Be also mindful of compute complexity. Now, if you've studied computer science, you might have heard of big O notation. For those of you who hated big O notation, don't worry, you're not going to be tested on that. Cribl makes it a lot easier to see what is consuming your compute time. In particular, be aware that nested for loops, when you combine regexes, often will work fine at sample scale of, say, 50 events, but will consume a large amount of time if you run through 50 million events. So be sure that within Cribl, you have this pipeline profile tool that you can look at as you're developing your pipelines, and it very nicely graphically shows you where the hotspots in your pipeline are that are taking a lot of time. You also want to avoid duplication, except when you have to. So one of the drawbacks of OCSF and the common criticisms is it does introduce some duplication of data. If you are fully populating it, there are a lot of fields that are very similar, and that is one of the drawbacks of some of these standards. One of the patterns that we will say thank you to John Rust with Cribl for is this unmapped pattern, where we flatten all of our data out, we pull keys off it, and this gives us the ability to see what keys have already been used, as well as what keys haven't been used, and accelerated our ability to quickly generate these mappings. So software development practices are something that, as I talk to security engineers, I find are not maybe as commonly known, so let's spend a couple minutes talking through those. The biggest cornerstone of modern software development is testing. We love testing. We want to find problems in tests and not when our users report them. So Cribl makes it really easy to capture real-world data as samples. Be sure to use that. Pay special attention to events if you're, in our case, looking at WAF logs. If you have suspicious payloads that you know are a problem, capture a sample of that. If you have atypical requests that you're aware of, capture a sample of that. If you have fallback cases, for example, if you expect that when a field is missing, you want it filled in with some placeholder data, have a sample of that you can test on. You also want to carefully consider your failure cases. We talked a little bit about this in the context of code blocks, but you also want to be aware of some of the logical assumptions that you're making. At Adobe, we ask all of our vendors to not send us request body data because it can contain PII, and we don't want to have that stored long-term in this particular data lake. Vendors are usually good about applying consistent configurations. Some of the open source tools, and I'll pick on ModSecurity a little bit here, maybe less so. So the example on the left shows us how in some configurations of ModSecurity, we were letting through request body data when we were testing, and we needed to make sure that we considered that case and took steps to mitigate it on the Cribl side in case the vendor didn't fulfill their side of the desired configuration. Also call out, use a staging or non-prod environment. The extra cost and resources are worth it to be able to test changes before you impact your production environment. Even better, set up CI/CD processes to run test queries and validate that you're getting the expected output. We'll call out that starting simple is great. It gives you a place to iterate from. A simple check or even one check is better than nothing if it's automated. You also want to use versioning. Our current model with packs is cloning and appending a version number manually, but Cribl is adding a lot of great functionality that will allow us to automate this process and do it more within the Cribl product, which I'm looking forward to greatly. All right, so if you're at the keynote earlier, you may have heard AI mentioned a time or two. So let's talk about how we used AI as part of this project. Now, we started this project before Cribl Copilot was available. So we looked at the tools that were available at that point, which were ChatGPT, Cursor, Claude, and Gemini. The general pattern that we followed was giving the model the JSON schema that OCSF publishes, and then a sample of the data that we had captured also in JSON format. Cursor performed the best. It got around 50% of the desired mappings. ChatGPT, Gemini, Claude, all closer to 30%. At the tail end of our project, we had Copilot released by Cribl, so we explored that as well. Cribl Copilot automates a lot of that capture and populating the model with the sample data and the OCSF schema. So the UX is vastly improved over manually working with these tools. It's nicely integrated in the Stream product, and it also got us to about the 50% mark. So what are the takeaways around AI? Well, first, manage your expectations. At this point in time, AI will get you started and will get you half of the way there, but it isn't going to build out your pipeline 100%. Now, this isn't to say that you shouldn't use it. You absolutely should. If I could shave off 50% of the time it takes me to do something, I count that as a huge win. So please don't take this as a negative reflection on AI. I will call out that complex logic is really the biggest stumbling block for all of these models right now. So these typically involve multi-stage conditionals, where, for example, you're looking at if the device coming in is a desktop or a mobile device, and then adding conditions based off of that, sometimes multiple levels of conditions. And the current models just don't handle that very well. So you're likely going to be building that out yourself. But before you do that, this is a good opportunity to say that ask yourself if you need the complexity of some of these very elaborate multi-stage conditionals. What value are you getting from this evaluation? So what are some of the takeaways? What did we learn from this process? I'll rehash again. Ignore the human factors at your peril. Identify your stakeholders early and connect with them often. Build your consensus up front. It's much easier to engage and involve people at the beginning of your project rather than at the middle or at the end when you're nearly finished. Also ensure that you have adequate resources to complete the project, especially with people. One of our biggest struggles was sharing people resources with other initiatives within our division, and it made it hard to get the right set of eyes on the transformations to validate that they were doing what they were supposed to do in a timely fashion. You also want to make sure that you're aligning with other vendors that you might be using. If you have vendors that are using a certain schema, it likely is to your benefit to use the same schema. And remember that creating your own schema is riskier and more time-consuming than you might think. Now, you might get through your first schematization effort and you've built that muscle memory of developing these things and you think, okay, we've got our WAF logs in OCSF schema. We're going to put our application logs in OCSF. I'm going to put DNS logs in OCSF. I'm putting my grocery list in OCSF. And stop and resist that temptation for a moment. Avoid the shiny hammer syndrome. We talked earlier about how schematization makes a lot of sense if you have lots of disparate data sources with a lot of different schemas. If you have only one data source that you're looking at, schematizing may not make sense unless you have a clear use case for doing so. Remember that schematizing is not free. We talked about the compute costs, we talked about the storage cost, and don't discount that your time has value as well. The time you spend schematizing is time you're not spending working on something that might be more valuable to your company. We talked about designing for growth. I'll call out comments and documentation are what none of us like to write, but are immensely helpful if you have to pick up a project that someone else has started. Especially with some of these more elaborate transformations, it can be really challenging to figure out what someone else was thinking. So help the future engineers working on your pipeline to understand and be able to maintain what you've built, and that will help it continue to be used into the future. And also be aware of the computational complexity. We talked about the issues that you might see at 50 million events might not show up when you're testing on a smaller data set. So be mindful of that occurring as you continue to scale up. And lastly, we'll call out following software development best practices. Versioning especially allows you to work with multiple iterations. You can have different versions in a non-prod and a prod environment. And in a worst case scenario, you have something that you know is a known good state to roll back to. Peer review is also something I'll call out. Cribl makes it very easy to open the window, commit and deploy, and hit that blue button, and your changes are in prod. If you are making a change that you're not sure of, that you think might have impacts that you hadn't considered, bring in a coworker, bring in someone else to review those changes and help you out. It is a solid practice that we adopt in software development that doesn't happen as much across security. And related to that, with testing, having a non-prod environment is enormously helpful so that you don't disrupt your users in production. Your compliance people especially will thank you when you aren't losing them chunks of data because of a bug that you pushed out by accident. So what's next? Adobe is exploring OCSF identity and access management with authentication as our next effort. As you might imagine, we have a large number of disparate data sources that produce authentication data that we're interested in querying and gaining insights over. And we're continuing to partner with Cribl to implement some new GitOps features and AI capabilities as they become available. We have seen time and time again that AI is advancing incredibly rapidly. The Copilot experience I had a month ago when I was designing this presentation is likely vastly inferior to what you can get out of Copilot today. So it's very exciting to see how fast that space is moving and advancing. So I want to thank everyone for your attention. If you're asleep in the back, I hope this was a restful nap for you. If you'd like to connect with me further, my information is there, and I hope you enjoy the rest of your conference.